AC power generation, also known as alternating current power generation, is the process of generating electrical power in the form of alternating current, AC. AC power is the standard form of electrical power used in homes, businesses, and industries worldwide. Here's an overview of AC power generation. Generator. AC power is typically generated using electric generators, which are machines that convert mechanical energy into electrical energy. Generators can be driven by various sources, including steam turbines, gas turbines, water turbines, or internal combustion engines. Principle of alternating current. AC power is characterized by the periodic reversal of the direction of current flow. It is generated based on the principle of electromagnetic induction. When a conductor, such as a wire, moves in a magnetic field or a magnetic field changes around a stationary conductor, an electromotive force, EMF, is induced in the conductor, creating an alternating current. Synchronous generators. The most commonly used generators for AC power generation are synchronous generators. These generators have a rotor that rotates at a constant speed and is connected to a prime mover. The rotor's magnetic field interacts with the stator windings, inducing AC voltage. Stator and rotor. In a synchronous generator, the stator consists of stationary wire windings arranged in a specific pattern, typically three-phase windings. The rotor, which is mounted on a shaft and rotates within the stator, includes a magnetic field produced by direct current, DC, excitation or permanent magnets. Voltage regulation and control. AC generators are designed to produce a specific voltage and frequency. Voltage regulation is achieved by controlling the excitation current or the field current supplied to the rotor. Additionally, control systems monitor and adjust the generator's output to maintain the desired voltage and frequency within specified limits. Power transmission and distribution. AC power generated by generators is typically stepped up in voltage using transformers for efficient transmission over long distances. High-voltage transmission lines carry the power to distribution substations, where it is then stepped down to lower voltages for distribution to homes, businesses, and industries. Three-phase power. AC power generation often utilizes a three-phase system, where three separate sets of windings produce three alternating voltages with a phase difference of 120 degrees. This arrangement provides more efficient power transmission and is commonly used in electrical grids. Grid synchronization. AC generators need to be synchronized with the existing power grid before connecting them to ensure proper phase alignment and frequency matching. Synchronization equipment and control systems are used to ensure a seamless connection without disruptions. AC power generation has become the standard due to its advantages, such as efficient power transmission, ease of voltage transformation, and compatibility with a wide range of electrical devices and equipment.